Hello and welcome to this lecture on Laplace transform. In this video, we will study about the concept of initial and final value theorem and we will solve a problem with it. First, what do you mean by initial value theorem? So simply, if any function f of t, okay, and its Laplace transform, if I am finding a Laplace of f of t, I will get capital F of s. If that exists, then we can use the initial final value theorem. So first thing, if f of t is there and if there exists the Laplace of this function, then limit t tends to 0 f of t will be equal to limit s tends to infinity s capital F of s. Okay, so this will be equal. Then if we go for final value theorem, it is a reverse process. Here t tends to 0, here t tends to infinity, here s tends to infinity, here s tends to 0. That's all. Remaining are same. Okay, so I have given a problem. We want to verify this function whether it satisfies the initial and final value theorem. Okay, so first of all, what I want to know, we need to solve this, we need f of t and capital F of s. What do you mean by capital F of s? If I am finding a Laplace of any f of t, we used to say that is capital F of s. Okay, so we have f of t, so we need capital F of s. So what I am going to do, I am going to take the Laplace of this function. I'm going to take the Laplace of this function. So simply a Laplace of f of t will be equal to capital F of s. So Laplace of f of t will be equal to Laplace of 1 plus e power minus t sin t plus cos t. By using the linear property, we can split the function by taking out the constants. We know that Laplace of 1 will be 1 by s. Now we need the Laplace of e power t into sine, e power minus t into sine t plus cos t. To find this, we need to go for first shifting theorem. So here the first shifting theorem will be in the form of Laplace of e power minus at f of t. If I am finding a Laplace of any function like this, the exponential and the f of t, it will be equal to Laplace of f of t, where s goes to s plus a. So we know that Laplace of f of t will be capital F of s, and we have to substitute s equal to s plus a. So finally it will be f of s plus a. There is the another one form, e power at f of t will be equal to Laplace of f of t, where s goes to s minus a. We used to say f of s minus a. Okay, so here we have e power minus t. F of t will be sin t plus cos t. To find the Laplace of e power minus t into f of t, here it is minus of, so we have to follow this term. So e power minus at f of t, where we want to first find the Laplace of f of t, then after finding the Laplace of f of t, we want to substitute s equal to s plus a. Then finally we get f of s plus a. To find the Laplace of this type of functions, we have to use this formation. So next what I'm going to do is I will use this step. So first of all, this we call it as f of t. To find L of f of t is needed. So I am going to find Laplace of sin t plus cos t. By using this linear property, we can split this into sin t plus Laplace of cos t. We have a formula. Laplace of sin at will be a by s square plus a square. Laplace of cos at will be s by s square plus a square. Here a will be 1 on both sin and cos. So here sin t will be 1 by s square plus 1 plus Laplace of cos t will be s by s square plus 1. So while adding both denominator are same, so we used to write s plus 1 divided by s square plus 1. Okay, and then we find this we call it as Laplace of f of t. What I have to do next? I have to substitute s equal to s plus a. So this is the final value before substituting s equal to s plus a. Here the value of a, we have to go for this. The value of a will be 1. So we have to substitute s equal to s plus 1. So finally, after finding the Laplace f of t, I am substituting the value of s as s plus 1. Then s plus 1 whole square plus 1. So this will be the final value for this Laplace of e power minus t sin t plus cos t. Okay, so this is the final initial value and final value theorem. I'm now going for the initial value. These are the calculation based on the initial value theorem. So let's see. So here I'm finding a Laplace of 1 and Laplace of sin t plus cos t. What I have did before. This is the same. And now I am using a first shifting theorem. So for this we need Laplace of f of t where s goes to s plus 1. S plus a means here a value will be 1. So for this we find the Laplace of f of t. This will be s plus 1 divided by s square plus 1. And while after finding this I am making a substitution over here. Okay. So here it will be Laplace of, what I am doing here is Laplace of f of t. So this will be s plus 1 by s square plus 1. Finally s goes to s plus 1. And I am substituting this value. I am getting this s plus 2 divided by s plus 1 whole square plus 1. Okay. So this final answer we call it as capital F of s. Okay. To verify the initial value theorem, we need f of t and capital F of s. Now we get both. This is our f of t they have given in the problem. Now we find capital F of s. So now we are going to verify this rule. So now let f of t will be 1 plus e power minus t sin t plus cos t. So this is given in the problem. So what I am going to do? I am going to take a limit t tends to 0 f of t. So that will be a LHS part of the initial value theorem. So I will substitute t as a 0. So it will become 1 plus e power 0 sin 0 plus cos 0. We know that sin 0 will be 0, cos 0 will be 1, e power 0 will be 1. So 1 plus 1 into 0 plus 1, it becomes 1 plus 1 equal to 2. So what about the next? We have to find the RHS part. The RHS part will be limit s tends to infinity s capital F of s. So we need to find this. So first already we have find capital F of s. It will be 1 plus s plus 2 by s plus 1 whole square plus 1. So we want to multiply s with this and I have to find the limit. So what I am going to do, I am going to multiply the s with this function and also I am going to take the limit. So it will be s plus s by s, then s square plus 2s divided by s plus 1 whole square plus 1. So on the next step I will get s tends to infinity 1 plus s square plus 2s divided by s plus 1 whole square plus 1. Now if I substitute, we can split this term. Limit s tends to infinity 1 plus limit s tends to infinity s square plus 2s divided by s plus 1 whole square plus 1. So to evaluate this step up to this, we will calculate this 1 plus limit of s plus s, that will be s square plus 2. So while taking the limit s tends to infinity of this term, how do I get the 1? If I substitute infinity to s, I will get infinity by infinity. When I substitute s tends to infinity, this whole term, it will be infinity by infinity. Then limit of any constant value will be a constant again. So limit of 1 will be 1. So limit of this term, I am getting infinity by infinity, but I have written as 1. How do we solve this? So we have to use L'Hospital rule. That means we have to differentiate the numerator and denominator first one time. So if I differentiate this, what will be? 2s plus 2 divided by 2s plus 2. Then just take the limit now. If I substitute s equal to infinity, again I will get infinity by infinity. So again I am getting the indeterminate form. So next we have to differentiate this numerator and denominator again. So it will be of 2 by 2. Now just take the limit s tends to infinity. 2 by 2 means at the cancel I will get 1. So limit s tends to infinity of 1 will be 1. So only I have written as 1. 1 plus 1 will be finally 2. Therefore I am getting this LHS part as 2 and now I am equated the RHS part to 2. So finally LHS equal to RHS. So the initial value theorem is verified. Now I am going to evaluate the final value theorem. Already the same problem we have find the capital F of s. What is our capital F of s? It will be 1 by s, then s plus 2 by s plus 1 whole square plus 1. What do you mean by f of t? What they have given in the problem? It will be 1 plus e power minus t sin t plus cos t. So this is the given problem. We have find the capital F of s. So now I am going to take the limit t tends to infinity for this function. Okay, so I may write this f of t in clear manner. So it will be of plus 1. F of t will be 1 plus e power minus t, then sin t plus cos t. See, if I am taking the limit t tends to infinity for this function, sin t plus cos t. So what will happen? Again, limit of t tends to infinity of 1 plus limit t tends to infinity of e power minus t sin t plus cos t. We can split this term. Limit of any constant will be a same constant again. So if I substitute the limit t equal to infinity, what will be there? E power minus infinity, then sin infinity plus cos infinity. Before evaluating this, we don't know this, but e power in minus infinity, just see the curve of the exponential function. So we know that e power 0 will be 1. E power 0 will be 1. here it is plus infinity, here it is minus infinity. So while this function, this is a curve of e power x, while this function is increasing in the value of x, in the positive value, while approaching infinity, it goes to infinity. So e power infinity will be infinity. If I am approaching less than 0, while approaching to minus infinity, it comes closer to the x-axis and reaches 0. So e power minus infinity will be 0. So therefore 1 plus 0 into sine infinity plus cos infinity. We know that 0 into any of value, we will get 0. So finally I am getting that value 1. Okay. So on the next, we are going to evaluate this on the RHS part. S tends to infinity, S capital F of S. So already we know that capital F of S will be this, while multiplying with S. Here it will be of limit S tends to, sorry, here it will be 0, 0, 1 plus S square plus 2S, then S plus 1 whole square plus 1. So the same process, we can split the term 1 plus limit s tends to 0, s square plus 2s by s plus 1 whole square plus 1, then 1, the limit of 1 will be 1. If I equate s equal to 0, 0 plus, here it will be 0, this expansion. So clearly 0 into anything 0, simply 1 plus 0 will be the final answer, no? So I'm getting 1. So I'm finding the LHS part 1 and RHS part 1. So therefore it is equal. So finally the final value theorem is verified.